Okay, so we're going to get started with lesson 1-2A, which is stepping it up to two-step equations. That means that the majority of our equations today will have two operations that were done to our variable, and therefore it's going to require two inverse or opposite steps before we get that fully isolated. Okay, so essentially, if you remember our lesson last time, we practiced a little bit of one-step equations that had addition or subtraction, and then some that had multiplication, division. Two-step equations essentially have one of each, one from each family, if you will, right? So it has something that was either added or subtracted, and then something that was either multiplied or divided. So you have to undo both. That brings up the really important topic of, well, which one do we eliminate first? Where do we begin? Now that there's more than one value to cancel, it means we have to decide order. So let's talk about that for just a second. So remember, if we were simplifying, if I knew what k was, let's pretend for just a second, just randomly, k is 4. And I was doing 4 times 5 minus 8. Order of operations would say, hey, you're going to multiply and then you're going to add or subtract, right? So let's review order of operations really quickly. I like to use this version of it because the reality is that there's all kinds of grouping symbols, not just parentheses. There's definitely parentheses, but then there's the brackets. Sometimes we use those. There's the long division bar. There's the square root. There's the absolute value bars. There's a whole lot of different types of grouping symbols that we would have to tackle what's inside first. So I feel like the P for parentheses is a little limited. So we're going to go with just GEMDAS, which is anything inside a grouping symbol first, then exponents, then the multiplication and division come together as a package. And when there's more than one, we go left to right. And same thing, the very last operations we typically do, unless they're in a grouping symbol, is the addition and subtraction. Those come together as a package, and we evaluate them from left to right. So that is how we normally simplify using this particular order. We're going to be using this all the way through May when we're doing really complex quadratics. This will still reign supreme. This will still be our guide, right? Well, what I want to get at is that when, instead of simplifying like we did a moment ago, if I knew what k was, coming back to here, if I knew what k was, I'd be multiplying times 5 and then subtracting 8. That's what order of operations guides us to do. When we are solving, we're going to want to do this in reverse. So you can think of, solving as kind of hitting the rewind button and reversing all of the steps that were done so that we can get back to the original value. So for example, on number 1, if I know that whatever k is, it got multiplied by 5 first, and then they subtracted 8, and that resulted in the 7. Then when I go to undo that, I'm going to just go in reverse. I'm going to put back the 8 that I took away first, and then I'm going to divide by the 5. I always give my students the example of a present. Imagine I was being sneaky and I wanted to give my daughter a little surprise gift, but I didn't want her to know what it was. And so I just, I was being goofy about it. I took that little present and I wrapped it up in newspaper. So it was a big newspaper ball, so she couldn't really tell what was inside or what shape or size, right? And then I put that newspaper ball inside a box and I put the lid on it and I wrapped it up with a bow. Okay, and so then I give her present, and she's all excited. She's ready to go see it. What would be the very first thing she'd have to do if she wants to undo that and get to her present? Okay, well, the first thing she would have to do is undo the bow. Now, that's the last thing I did, but it would be the first step for her if she's trying to reverse or undo my packaging. She would have to undo the bow and then open the box and then pull her present out and then unwrap it. And you see, she would have to kind of reverse the steps in the reverse order than what I did them. Okay, so you can think of k as our little secret present that's our mystery and we don't know what it is, right? And we know that when it got multiplied by 5 and then they took away 8, it resulted in a 7. So I'm going to reverse those steps. that means, long story short, that the addition or subtraction, unless there's a grouping symbol involved, the addition and subtraction is the first thing you're going to undo. You're going to do the inverse operation or the reverse of that first. Then you're going to go to the multiplication and division category and undo that next, okay? So let's start with number 1 now that we know what order we're going to tackle these in. Identify where your variable is. There's my k. My operations were multiply by 5 and subtract 8, so I'm going to do the reverse of that. First thing I'm going to do is add 8 on both sides. Okay, that cancels this out here because that's just 0. And this time around, it doesn't quite get us all the way to the answer, but it gets us closer. So when I add 8 on both sides, on the left side, I now just have 5k. On the right side, my new result is 7 plus 8, which happens to be 15. Yesterday, we would have been done there. But today, we have an extra step. That got us k a little closer to being by itself, but not quite there yet because we still have to deal with the 5. So now we just do a second round to get rid of the 5. So if they multiplied by 5, the opposite of that is to divide, and we divide on both sides because 5 over 5 is 1, and that cancels the 5 out, and it leaves k by itself. So coming over here, now we have k is equal to, that's by itself now, and then 15 divided by 5 we know is 3, and that's our solution. And I've said it before, but you're welcome and probably pretty encouraged to check your answer. You can always plug that 3 back in and make sure that it works. You could do, even in your head, you could just say, okay, 5 times 3, yeah, that's 15. 15 minus 8, yep, that sounds good. That is 7. We did it correctly. Okay, I'm also, like I mentioned in class and on the last video, modeling the amount of work I expect to see and how I expect to see it. So this is what I'd be looking for. That inverse operation on both sides of the equal sign, inverse operation on both sides of the equal sign, showing all your steps and all your work, and that tells us how you arrived at your solution. Okay, all right, let's take a look at number 2. So on number 2, there's my variable is a w. They multiplied it by negative 3.2 and subtracted 2. So again, I want to hit that in reverse like we talked about here. I'm going to start off by eliminating the addition or subtraction. So that's this guy here. The opposite of this negative 2 or this minus 2 is a positive 2. That cancels. Okay. On the left side it cancels. It brings this term down. So now I've got negative 3 decimal 2 w equals, and then on this side I have different signs, so I'm going to find the difference here. I'm going to go ahead and subtract. My signs are different, and that's going to leave me with a negative 2.5 or decimal 5. Okay, and then I'm not quite done because I have that second round. So now to get w totally by itself, I still have to get rid of this. That's being multiplied, so the opposite is to divide. So we're going to divide both sides by negative 3.2. That way, notice that when I multiply or divide, we don't change the sign. We keep the sign. That way we guarantee a positive solution. So a negative divided by a negative cancels that sign, and it really does leave us a positive w. And then on this side, a negative times a negative also, a negative divided by a negative also cancels. And all I have to do now is evaluate this. Okay, so really w, the result or the answer here, is going to be whatever 2.5 divided by 3.2 is. Okay. No, you cannot leave decimals in a fraction like this. You will have to do this division and leave your answer as a decimal because it started as a decimal. And that's going to probably have us review a little bit of long division, and that is okay. That is good for the soul. So let's try it. If we do 3.2 on the outside and what we're dividing by is 2.5, the first review topic is the fact that you cannot divide by a decimal. So we've got to scoot this guy over enough times so that that is a whole number. Okay, so if I scoot that over, I rewrite it as 32. But of course, if I have to scoot this one unit over to the right, this one's got to do the same. So now I'm here. And the decimal now is behind the 5. Once I know that, I'll bring it straight up. And now I really am ready for the division here. So 32 does not go into 2. It does not go into 25. I'm going to have to add a 0 here. But 32 goes into 250. It does. And it goes in about 7 times. Okay, so then I'll multiply down 7 times 2 is 14. Carry the 1. 3 times 7 is 21. Plus the 1 I carried is 224. And I find this difference. So I'll borrow from you. Make that a 10. That's 6. That is 2. And that's it. Okay, so 26. I'm going to have to add another 0 so I can at least go a little bit further. I would like to go to at least the hundredths place and then round back. Okay, so let's do it again. I'm thinking that this is going to go in. Let's see. I wonder if I can fit another. What's the difference here? This was already 224. Yeah, let's go 8 times here. Let's see what happens there. So 8 times 2 is 16. Carry the 1 again. 8 times 3 is 24, plus the 1 I carried is 25. Ah, that's pretty close. All right, perfect. And we find this difference. I'll borrow from that. And that gives me 4, nothing, nothing. If I bring down another 0, just to make sure, I notice 32 goes in there 1 time. I'm going to stop here. This is enough for me to see where this is headed. 0.78 is what I can round to if I'm rounding to the hundredths place, which is usually where I try to stop on a decimal like this. And there's our solution. Okay? So that one wasn't very nice, but, you know, it's okay. We need to review our long division. Pretty soon we'll be able to use calculators. Not yet. I want to see this work on these first few weeks, but then after that we'll be all right. All right, let's try number 3. On number 3, there's our variable. There's n. Here are our operations, okay? I'm always going to start with whatever was added or subtracted first, which is our 13 here. So that is a positive 13. The reverse or inverse of that is a negative. That's what's going to zero that out. So if it's not connected to my variable, I want to do the opposite sign and just make it be 0. That's kind of another rule of thumb to use, right? So if it's not directly connected to the variable, if it's added or subtracted, then I just want to do the opposite sign so that it becomes 0. Be careful here. That negative belongs to the 2, so that's still a negative 2n. Equals, and then on this side, this difference, 27 minus 13, that's going to be 14. Okay. Step 2 then is to get rid of the negative 2. So we'll divide both sides. Now in division and multiplication, we don't change the sign. We want to keep the same sign, so guarantee a positive variable. So if it's a negative 2, we'll divide by a negative 2. We'll keep the sign the same. Okay, and that way the negative and the 2 cancel. N stays positive, and my result is just 14 divided by negative 2, which is a negative 7. Okay. All right, let's take a look at number 4. All these lovely decimals. Okay, there's our variable. They multiplied it by 5.25 minus 2.01, so I'm going to go in reverse. First thing I'm going to do is get rid of the addition or subtraction by doing that inverse. So again, the one that's not connected, we're doing the opposite sign. Cancel that on both sides. This comes down, so now I have 5.25s. And on the other side, I have whatever this difference is. Let's find out. 4 minus 1 is 3. 9 minus 0 is still 9. Negative 8 and a positive 2 is a negative 6. So I've got negative 6.93. Lovely. Okay, and then we will divide both sides by that 5.25. 5.25. Okay, so our result here for S is going to be, and I'm going to have to kind of, in fact, I'll put it over here. S equals whatever this division is. So again, we'll have to kind of go off to the side and do a little bit of long division here. We'll move this decimal. Well, our original is going to be that negative 6.93. In fact, I'm going to leave this off. I already know that a negative divided by a positive is going to stay negative, so I'm going to just write that in. That way I don't have to worry about that negative in my long division. This is 5.25. Okay, so again, I cannot divide by a decimal. So I need to make sure I scoot this over. Scoot it over enough to be a whole number. So it's going to look like this. And if I move this one over twice to get a whole number, this one's got to move over twice. So now this is really the division that we're going to be doing. This decimal is now behind the 3. And we can get started. So does 525 go into 6? Nope. 69? Nope. 693? Yes, it does. I'm going to go with 1. Pretty confident on that. 1 times 525 is still 525. Okay. Find this difference. So I'll borrow from my neighbor here. Carry the 1. 13 minus 5 is 8. This is now an 8 minus 2, which is a 6. And 6 minus 5 is 1. And then I'll have to add a 0 here so I can play this game again. So this is about 515. So if I were looking at just rounding, 5 would go into 16 about 3 times. So I'm going to try 3 here. Okay. So I'm thinking it might go in 3 times. So 3 times 5 is 15. Carry the 1. 3 times 2 is 6 plus 1 is 7. And then 3 times 5 is 15. All right, that's pretty close. Let's see, let's subtract. That's going to give us a 5, 7 minus 7, and a 1. Okay. And I can bring down another 0, straight down. And then we're going to try one more time. I'm thinking this might go in exactly 2 times. Let's try that, because I'm thinking 25 times 2 is 50, 5 times 2 is 10. So I'm going to try 2. So 2 times 5, 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. And 2 times 5 is 10. Boom. Nice. No remainder. It went in exactly 1.32. So that is our answer. Negative 1.32. Here's the value of S. Y'all see that okay? So, again, pretty soon we'll be able to use calculator. Right now, I expect to see that work. I'm modeling exactly how I would want you to do these. And these are new notes. In hindsight, I'll probably leave more room next time. Feel free to use a clean sheet if that helps. All right, let's try number 5. Hopefully this is more friendly. It doesn't start off with decimals, so I'll be able to either get whole numbers or pick. And when I have the choice, I promise you, I'm going to go for fractions probably because I think they're easier. But let's see what happens here. So here's P. There's our variable on the right side this time. I want to undo these guys. The one that's not directly connected, that's the one I'm going to do the opposite sign. So if I have a positive 51, what's going to cancel that is a negative 51. So I'm going to do negative 51 on both sides. That cancels. Okay, 84 minus 51 happens to be 33. And on this side, I still have that negative 14P. All right, next order of business is getting rid of that negative 14, so they're multiplying. The opposite is to divide. This time I'm going to use the same sign. Remember that, because that way I guarantee myself a positive variable, because a negative divided by a negative cancels, and the 14 cancels, and P is by itself. So I'm going to get P equals whatever 33 divided by negative 14. And this is where I'm like, ha, 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 look at fractions. They're so much better. Because a minute ago, because I was dealing with decimals, I had to go and do all of this work to figure out what that was. But if I have the option or choice to leave it as a fraction, guess what? I'm just going to leave it as a fraction, negative 33 over 14. And unless that reduces, unless there's a common factor that goes into 33 and into 14, I'm done. Not only can I just leave it like that and not have to do all that long division, but I also can leave it improper. In Algebra 1, we actually prefer improper fractions more often than mixed numbers. So it really is that simple. Just that's it. I would leave my answer like that, and I would happily go about my way. Okay. Okay. So I'm going to, I think you guys get the idea here. I'm going to jump to this one that does contain fractions. You're definitely welcome to check these out a little bit later. I'll probably go back and finish those. But I want you to look at the ones with the fractions here. On number 7, here's our H. They're multiplying by 4, and then there's adding that 1/3. So remember, we begin with the addition subtraction, the one that's not connected, and we cancel that first. So we do the opposite sign of this, which is a negative 1/3, and we do that on both sides. That cancels our fraction. It leaves us with just 4H on the left. On the right, this time they're not being quite as friendly with us. Yesterday, everything had common denominators when we had to add or subtract, or almost everything anyway. This time we're going to have to work a little harder for it. I cannot subtract or add these without a common denominator. So I'm going to have to come over here and rewrite these. Find that GCF, that least common multiple between 4 and 3, that LCM, which I'm thinking is 12. So I'm going to change both of these guys to 12. That's what I want. That's my goal. And then I have to think about, well, what would I have to multiply 4 by to get 12? Well, I'd have to multiply it by 3. So I'm going to triple or multiply this whole fraction by 3. So it becomes 9/12 instead of 3/4. So these two are still equivalent, just to review there. These are equivalent to each other. I've just taken the original. I've tripled the whole thing. Make sure you do the top and the bottom. And that way, it's an equivalent fraction that still represents the same fraction, but it has a common denominator that I'm interested in getting. And then I'll do the same for the second one. The second one is 1/3. I want a 12 there. I have to multiply this by 4. So I am going to take this whole fraction and multiply it by 4. Okay, so this one, I took the whole thing and I multiplied it by 3. This one, I took the whole thing and I multiplied it by 4. So 1 times 4 is 4 on the top. 4 times 3 is 12. So these guys are still 4 over 12 still simplifies to 1/3. These are equivalent to each other, but now I have the common denominator and I'm ready to find this difference. So once I have a common denominator, all I have to do is compute the numerator. 9 minus 4. That gives me a 5. And the 12 stays. The 12 is just your denominator, right? Once you found that common denominator, it just stays put. All right, so we were able to get the common denominator and do our math on this side. Now it's step 2. Step 2 is to divide by this 4 and get rid of it so that h is alone, right? Because our goal is really h by itself, okay? Well, they're multiplying by 4, so the opposite is to divide by 4. I divide by 4 here. Over here, I'll divide by 4. I'm going to write it this way just because I have a fraction in there. So this is what's happening. But remember, we talked about this. When we're dealing with fractions, we don't actually ever divide by a number. We do the keep, change, flip. Instead of dividing by something when we're dealing with fractions, we multiply by its reciprocal. So that means if I think of 4 as a fraction, it's 4 over 1. That means I'm going to rewrite that and say, okay, I'm going to keep this, and I'm really going to multiply it by the reciprocal of 4, which is just taking that 4 over 1 and flipping it over. This is really the math that's going to happen. When I divide by 4, I'm really going to end up multiplying by 1/4. Really, that makes sense. Taking a fourth of something is the same thing as dividing it by 4. So those are equivalent, but now I can multiply these guys. Remember, for multiplication, unlike up here, I don't need a common denominator. I'm perfectly happy with this, no big deal. As long as I know how to multiply 12 times 4, it's okay. So 5 times 1 is still 5, and 12 times 4 is 48. And if 5 does not go in there evenly, no big deal. That's the beauty of fractions. I am done. I can leave it just like that and move on with my life. It's good news. Okay? Let's try one more with fractions, and then we'll talk about a word problem. Okay? So on number 8, here's u. This is what I want to get rid of. First, I'm going to start off with what was added or subtracted and do the opposite sign. So I'm going to subtract 3/5. Again, I don't have a common denominator here, so I'm going to rewrite these with a common denominator. 6 and 5. Thank you very much. 6 and 5. I'm going to venture to say that the common denominator between these guys is a 30. So I'm going to want to rewrite these with a 30. Okay, that means I have to take this and multiply it by 5. That gives me 5 over 30. 1 times 5 is 5. 5 times 6 is 30. So this is still equivalent to that. And on this side, 5 times 6 gives me 30. So I'll take this and multiply it by 6. And that's going to give me an 18. Okay, so now I have a common denominator here. And 5 and a negative 18 is a negative 13. So that's the fraction when I combine these guys. And then again, if I'm multiplying by this, we don't actually divide by fractions. Instead, we multiply by their reciprocal. So there's that reciprocal again. I'm going to multiply both sides by the reciprocal of negative 1/2, which is negative 2 over 1. Notice I'm keeping the sign the same. In the multiplication or division, we do not change the sign. Okay, so I'm just flipping that fraction over to, this all cancels out. It just leaves u all by itself. And then on this side, you can multiply straight across and then simplify, or you can simplify first. Like I notice negative times a negative becomes a positive. I also know that 2 over 30 is just 1 over 15. I like to reduce first. So that leaves me with 13 times 1 is 13, and 15 times 1 is 15. But if you don't like to reduce first, you could have multiplied the originals, 13 times 2, that would have given you 26, and then 30 times 1 would have given you 30. And then I would have wanted you to see, oh, these have a common factor of 2, and I can reduce it, and guess what? You still get the same answer, so they both work. Okay? All right, moving on to number 9. So let's try a word problem here. It says you purchased $132.49 worth of wheels and bearings for your skateboard. The shop charges $15 per board to install these. The total cost is $192.49. So how many skateboards will be repaired? Okay, so let's set up the equation. We talked a lot about this from the last one. I always want to see an equation first, then I want to see the solution. So we already know that the cost to you is going to be $132.49 for the actual parts, that you need, the wheels and bearings. Plus, you're also going to have to pay $15 per board. So if X is the number of skateboards, so number of skateboards, right? In addition to what it costs you for the materials, you're also going to have to pay $15 for each of the boards for the person to do the labor and install those. Okay, so basically materials plus labor for each of the boards. When it's all said and done, your total ended up being $192.49. So we want to work backwards and find out how many boards did you have them fix, basically, or repair. All right, well, let's start. We're trying to solve for this, and kind of this is the idea. If this is your total cost, if you were thinking of this less of an equation and just more common sense, the first thing that I hope would run to mind is like, well, out of that $192.49, $132.49 was just materials. So this doesn't have anything to do with how many boards you are fixing. It's just what you paid in materials. So I'm going to subtract that, okay? I want to find out how much was it just for the labor. So when we subtract that on both sides, again, we're starting with the addition or subtraction and eliminating that first, okay? That leaves us with 15x equals, well, let's find out. 9 minus 9 is 0, 4 minus 4 is 0, 2 minus 2 is 0, 9 minus 3 is 6, and 1 minus 1 is 0. So basically 60, okay? So there was a difference of $60 here. That must have been what they charged you for fixing the boards. Well, if it's $15 per board, if I divide that by 15, 60 divided by 15 is just 4. So there must have been 4 boards, right? So how many skateboards will be repaired? It will be 4 skateboards. Okay, so there's that one. Let's try the last one here. A music download service charges a flat fee each month and 99 cents per download. Okay, so if I think about an equation, right, there's some flat fee that I don't know, plus 99 cents per download. And that's my total cost. So there's a fee. In fact, if you want to use F for that, that's totally fine. There's some fee plus 99 cents per download. Together, that tells you the total cost for downloading the music. Okay? Then it says the total cost for downloading 27 songs. So that tells us this. We downloaded 27 songs. So it's 99 cents per song. And the total cost was $42.72. And we want to work backwards to see what was the flat fee. That's what we're looking for, is F here. So there's our equation. We know when we download 27 songs, the cost ends up being $42.72, and we want to work backwards to find out what the fee is. Okay, so if we do this, oops, sorry, not equals. So the fee plus, first let's find out, well, if we downloaded 27 songs, how much money was that? So we're going to multiply these guys together. Okay. So we'll do that. 9 times 7 is 63. And that's also 63, plus that is 69. I sure hope that's it. See, yeah. And then we put a 0, and then we go with the 2. 2 times 9 is 18. This time we carry a 1, and then that's 18 plus 1 is 19. And then we add these guys up. 3. This is 17, carry the 1, that's 16, carry the 1, that's a 2, and then we have 2 decimal places, so we got to scoot this over twice. So it looks like we end up paying $26.73. So $26.73 was from downloading music. So if I subtract that, it'll tell me how much the fee was. Like that. So the fee is going to be whatever this difference is. Okay, so let's see, we got to borrow from our neighbors here. Borrow from here, we make that a 12. 12 minus that is 9. And then, oh, I got to borrow from this guy, make that a 16. That makes that a 9. I got to borrow from this guy, make that an 11. That's a 5. And that's a 1. So I'm looking at a fee. The fee is $15.99. And again, I like to check the work there just to be on the safe side. So I would reach for the calculator and make sure that that makes sense and make sure it works. All right, and here's the great news, guys. You do not have to worry about the back page. The back page is a typo from another assignment, so you can just go, hey, none of this is for us, woohoo! We'll deal with that later at another time. So all you have to worry about is 1 through 10. Hopefully that jogs your memory on how to solve two-step equations. I will see you tomorrow.